What is plant sap analysis? And that's what we're going to discuss on today's episode of Blueprint to Yield. Hey everyone, Mike Evans here with Cultivating Agronomy. I got Clint Frese over there, and we're privileged and honored to have the man from New Age Labs, the owner, Scott Wall. Scott, thanks for coming.
Oh, thank you for having me. I appreciate it.
We'll let in with what is plant sap analysis.
Well, I think the simplest thing it is it's a report card on how well your crop is taking up nutrition. You know, when we try to start getting more sciencey about it, it's a process in which the laboratory you send your plant tissue to is going to remove from that petiole or leaf blade, or a combination of both. They're going to remove the fluids from that leaf blade and petiole. They're going to remove the fluids, and then they're going to analyze those fluids, preferably the xylem and the phloem only. And they're going to analyze those for a list of parameters that we're going to use to assess whether or not that crop is feeding properly, taking up nutrition, whether it's using that nutrition completely and adequately, or giving good return on investment. Ideally, you have to think of your crop as production implements out on a production floor. And if they're not photosynthesizing at 100%, then you're getting less out of all the production units out in that field. So it's our job as the managers to make sure that everything is producing at the highest possible percentage of productivity. Mm-hmm. And that's what plant sap does. So, when we're talking about New Age laboratories, what we're doing specifically that most other labs or plant sap labs, and there's only about a handful, 5 or 6 globally that are really doing this. And how we're different is that we're focused on taking the fluids only from the xylem and the phloem, the vascular bundle in the leaf blade and the petiole. Okay. So that means we don't want to violate any of the...
Does all labs do that, Scott?
No, they don't.
Some of them actually push hard enough to get all of it out of the cells. Is that correct?
Yeah, they'll use a variety of different techniques. The other labs globally might masticate the tissue. So like you've heard people say, use a garlic press, right?
Yeah.
So in that case, the leaf blade is going to be ground up. Okay. And then they say then you press it down and you get a drop out onto something. Well, now you're getting into cells and you're getting into fluids that are already committed to the cellular structure of that leaf. Okay. And those aren't nutrients that are readily available in the physiology of the day-to-day, what's going on that moment. We only want what's actively mobile in the xylem and the phloem, okay? So we're going to put a linear pressure on that leaf blade and tissue that you sent. And we don't want to violate the tensile structure of the cells. So we don't want to break them open. So we don't freeze it, we don't masticate it, we don't grind it up, none of that. And then we just put a linear pressure on it, allow that sap to seep out of the cellular, the vascular bundle, and then we collect that up, and that's what we're going to analyze. So that way, when we look at the data between the new leaf and the old leaf, we're really looking at how that crop is partitioning nutrition between the source sink. So when we talk about Marshner, right? I tell everybody, look, if you want to learn about sap, start with Horst Marshner's book and learn about source sink relationships. Well, that's because that's what we're depending on. We're depending on the crop to actually teach us where it wants to be nutritionally.
Yeah. So you just laid out it's pretty technical and integral getting this analysis out, right? That pressure is so critical.
It is. Every crop has its own tensile strength. Like you can't take lettuce and put the same pressure on that as you would, say, a macadamia. macadamia leaves from Australia, much tougher. They can take a lot more pressure than lettuce can. Even corn. Okay, so if we're doing corn that's very young, say a V4 leaf, that's going to take a lot less pressure than VT.
Gotcha.
VT's a lot tougher. It's hardened off. It's going to take a lot more pressure. So you've got to change that throughout the season before you can violate the tissue. And then you're getting into things that you don't want to see. You're going to get into seeing elevated potassium levels, because potassium is used within the cells for osmotic balancing. You could get elevated manganese levels because you're breaking into the waste vacuoles. Only 5% of the manganese that's taken up by the plant stays available to the plant. It's readily moved into the waste vacuoles. Well, if you start breaking in those vacuoles, you get an elevated level of manganese and you get a false interpretation of what's available. Why do you see such high levels of manganese in dry tissue? Because you look at everything in the leaf. That's why dry tissue isn't functional. It gives us a false interpretation of what's going on. Why do we care how much that there's 100 ppm of total manganese if 95% of it's sitting in waste vacuoles and never going to be? That just means we accumulated a lot of manganese.
Yeah.
It doesn't mean that we had manganese available in the growth stage that we're working in. And that's what sap analysis really gives us.
Yeah.
It's what's going on today.
Yeah. And then I think that, we made a comment just a little bit ago about that's the question we get, Clint and I get, tissue versus plant sample analysis. And I think why'd you go down that path? I think that path, why did sap analysis trigger you to go start doing and become New Age Labs and really dive into it and bring it to the market?
Well, I think it was kind of a confluence of three things. One, we had a lot of growers that were using dry tissue that we provided, and we still do. And you do dry tissue, and it didn't correlate with what they saw in the field. They were seeing deficiencies. The dry tissue said, well, you were within sufficient ranges. So non-functional, didn't serve a purpose. No actual management came out of it. At the same time, I was going through chemotherapy for leukemia, and I wanted to see better, healthier food. And we didn't have a good way of managing crops for nutrient density and healthier crops in general. And then thirdly, we were, myself and Brian Krieger, who is my director of sales, we were out on a blueberry growers field day, similar to what we do here. And we were hearing about how growers in Michigan were sending samples all the way over to the Netherlands for this test, plant sap analysis, that was supposed to give them real-time data, but the turnaround time was anywhere from 8 to 10 business days. Yeah. Well, it's like, how much real-time action can you take if it's taking you 8 to 10 days?
Yep.
And we looked at it and we said, well, we can do that analysis in the lab that we have right here in West Michigan and help our blueberry growers out. We just needed to know where the numbers needed to be.
Yep.
If we got the numbers, where was a good number, where was a bad number?
Yeah.
So that's when I had to start learning Horst Marschner.
Yep.
And source sync and so on and so forth.
Speaking of that, what are good levels? The other question we get with plant sap all the time, I'm never achieving my OLs. and so one of the things we walk through customers and farmers with is, the bar is set pretty high with sap as far as the operating levels or your benchmark levels. But I think it's important for the farmer to think about what his crop is. How big is the stalks? How big are the leaves? How much, do we got a big plant that has a ton of consumption? Could you take us through that a little bit on what you've seen over the years regarding that?
Yeah. I think the first thing to realize with sap analysis is that it is not soil analysis. It is not dry tissue analysis. On the reports that we put out, and even the reports that Novacrop, who is the biggest competitor we have globally, when I say sap analysis, it's us and Novacrop. In dry tissue and in soil, you always have a range that somebody says, okay, well, I have to fall in this range, or it's low, medium, high, that kind of thing.
Yep.
And everybody expects that when they get a report from a lab, it's supposed to tell them if I'm good or bad. And sap analysis, in order for people to accept it early on, we made our reports with a optimal range. First of all, there is no such thing as an optimal range. Okay, I don't care who's putting out a report. And for someone to tell you they've done an optimal range, that means that they've run a myriad of tests and they've held every parameter static and only changed one and ran it through an entire season at various levels and measured the yield and measured everything else and kept everything else stable. Nobody's done that kind of work. They didn't do it on dry tissue. They didn't do it on sap. They've never done it on soils. So optimal is a figment of our imagination. Mm-hmm. But with sap analysis, and particularly comparative sap analysis, which is where we're looking at new versus old. Okay.
Yep.
Mm-hmm.
So source sink, we can let the crop tell us where it wants to be. Now, we use the OLs as a gauge, okay? And our database dates back to the mid-1980s, okay, with a gentleman named John Hall from Australia who developed this. So our database is over 40 years old in its origination, and we've just kind of kept rolling it along. Mm-hmm. But it's not about the number. It's about the relationship between the new and the old, particularly for phloem mobile nutrients. Okay? So your big ones, phosphorus, sulfur, potassium, magnesium, nitrogen. Okay, here's your big hitters, right? And a lot of your micronutrients are semi-phloem mobile. So instead of looking at the number and saying, am I in the range, you want to look at the new versus the old. And if the concentration in the new is less than the concentration in the old, that means that the crop is telling you, I'm satisfied with my uptake from the roots. Mm-hmm. I've got more than enough, and I'm going to store the excess in the old tissue. Okay, great. Now you know where it wants to be. That, and when I mean that crop, I mean not only that crop, I mean the variety of the seed that you've put in, or the variety of the cherry tree or the acorn squash or whatever you're growing, because varieties feed differently. Seed corn is not all the same. Some seed corn feeds heavy, some seed corn feeds light.
Yeah.
And if I'm going to get 150 bushels per acre, I might as well have one that feeds light because it's going to save me money. So now flip it upside down. If the concentration, if I have 250 in the new concentration and I have only 200 in the old, that's the crop telling me that in that growth stage with my management style, it is not getting enough nutritional uptake through the root zone. So it is stripping that nutrition from the old tissue to feed its demand in the critical sink, which is the new growth point, or into the fruit fill. Okay? So it's stripping it. It's feeding off itself to meet its demand that it's failing to get from what you're providing through the root zone. Okay? So that's where we go with these OLs. And it's not about trying to meet the OLs. It's about meeting what the crop is telling you it wants. I think the micronutrients are the hardest ones, right?
They're so consumptive. They're used so much.
You're right.
In all so
exactly.
many reactions.
And everybody's like, I have such a hard time meeting it. Well, you're having a hard time meeting it because, one, the microbiology in the soil is poor. And you can't mineralize microbiology if you don't maintain good, you can't maintain micronutrients without good microbiology. Microbiology depends on good pH in the root zone. We screw up way too much pH in the root zone all the time. It's constantly shifting, and therefore your microbiology, your micronutrient uptake is constantly going to shift. So the easiest way to take care of micronutrients is through foliar. In season, treat micronutrient deficiency with foliars and make sure you have a healthy, robust supply of micronutrients. That will feed your macronutrients and your essential nutrients, and the crop will feed itself from there.
Well, and I think that's what's interesting. We're pulling so many saps now, got a bigger database. We've, very much a believer in biology. It's very much our customers, we're pushing on them to be involved in the biology and really get biology active. We've noticed that a certain micronutrients, silica and manganese, I think you first brought it to our attention, elevate when we get biology really rampant.
Yeah.
And so what we've done is, created micronutrients that are still where our weak links are: boron, zinc, copper, iron, moly, and where we're using our biology to get manganese and silica at an elevated level. So that was a stark contrast from tissue.
Yeah.
And I feel like it's much more accurate.
Yeah. And what have you seen with that?
As far as when we go and deploy those, we see macronutrient efficiency seems to get better, and late season plant health definitely gets better. So I would say those two things.
Exactly. And what I keep telling, every year we have neophytes to plant sap, right? The new guys. And then over here, we've got guys that have been doing it 4, 5, 6 years. And these guys are like, this is tough. I don't know. What am I supposed to do? I said, stick with it. And the guys over here are like, man, I don't know. I'm doing well and everything's improving, but it seems like I'm not on point yet. And I said, no, you're on point. It's just that think of plant sap analysis and what you're doing. It's like a video game. And every time you answer all the right questions and unlock all the keys, you go to a next level in the video game.
Yeah.
And now the challenge is harder. The plant goes to a new level of biology and plant physiology, and it wants to do more. And so now it needs a different balance. And when you supply microbiology, you can only do so much with chemistry. But when you start adding microbiology, you take it to another level. And now it can do so much more plant physiology-wise and photosynthesis-wise. And now it's really popping now. Now it's photosynthesizing, it's producing lipids, it's producing fats, and it's going places you never thought that crop could go. You've never seen it before, When we talk about scoring a field, when you get new people, they rate all their fields as 4s and 5s. And that's on a scale of 1 to 5, right?
Yep,
so everything's excellent, it's great. And it's like, okay, wait a minute. You're not coming to us because everything's great. You're coming to us because you think you've got places to improve, right?
Yeah, exactly.
And you teach them, it's like, just because it's green, it just means it's alive. There's a whole other place to go to beyond just being green and alive.
You bring up a great point with that comment, Scott, that plant health, and everybody assumes, I got a big dark green plant, I got a healthy plant.
Yep.
And I was under the same impression as I've grown in this industry and in the career. And you see it top to bottom green, everything is great, and you're like, I got a healthy plant, I'm doing things right. And then you go, look at a plant sap analysis, and you're like, well, that ain't right. I got weaknesses. How's that possible, right? And then you start going down this path and start fixing those, and you really kind of transform the crop to some degree. You start having to look at it a different way. And green, like you just said, green doesn't mean it's healthy.
Right.
Explain that. I mean, I think that's an interesting concept.
Well, if the plant's not green, it's going to be yellow, or it's going to be red depending on what is missing, right?
Yep.
So, but by the time you see that, it's so far down in deficiency, you're losing a ton of yield. But those deficiencies, those stressor points start appearing or happening to the plant well before they're visually present, right? And that's one of the great pieces of plant sap analysis, is that we can see deficiencies and excesses forming way before you ever visually see them in the crop, right? So when we start seeing a deficiency in potassium or a problem between the potassium-calcium ratio or phosphorus deficiency forming, you may never see it in the crop. And if you're a SAP user and you're proactive about it, we can see it happening in the SAP, catch it early. You can get out there and do a manageable action effect on a hidden hunger. So let's call it a hidden hunger, right? Yep. On a green plant. So it was green, but now we prevent that from causing a loss of yield. We can be actionable, get on top of it. But now we're just dealing with chemistry. When you guys start adding the biology and we start getting into the regenerative ag field, right? Where we're actually starting to get the plant where, say, our bricks are getting up into that 6, 8, 10 range, and our photosynthesis is really kicking in it. Okay, so 60 to 80%, depending on the crop species, of the sugars produced by the plant are put back into the soil as root exudates. Okay, those root exudates are configured by the crop to feed the microbiology in the root zone for the things that it wants most. So it's farming the microbiology in the rhizosphere to produce exactly what it wants. It's not arbitrary. It's not random. It's doing what it needs. It's not a thought process. But it's there. Now that feeds back and it takes up better nutrition. It photosynthesizes better because now it's getting all the things it wants. There's rhizophagy going on as well, so it's actually consuming some of the bacteria. And now it's getting to a point where it's a complete feedback loop. So you're farming, it's farming. The soil, healthy soils feed healthier plants, and it's feedback loop. And so now you're taking this whole crop to another level, farther than you could take it just as a farmer applying amendments.
So in a sense, the better job we do with mineral nutrition, the more carbon we pump into our soil,
right,
the better job we take care of our biology.
That's right.
And what we've found, especially since we started this whole SAP journey, we can't do that by putting all our dollars in nutrition before we even pull the planter in the field. So, I think that it's cool how this all works in a network. And, where we're reevaluating now is corn and soybeans. It's pretty much guaranteed you make one fungicide pass, if not two. Can you make the argument that if we would pay better attention to mineral nutrition and find our weak links, that we would have to reevaluate our disease because we have a healthier, tolerant crop?
Oh, I totally agree with that.
Yeah.
Yeah. I think we can look at our own population. I mean, there's individuals that take care of their own bodies. They have better immune systems. Therefore, they're capable of fighting off more illnesses. They don't get disease. And then there are people who eat a lot of junk food and don't take care of their bodies, and they're very susceptible to disease. That is true across every species on this planet. You guys have had Dr. Tom Dykstra. Tom Dykstra has been a guest on some of our podcasts for the lab. He's very clear about pests feed on weak plants. We believe in bricks. Bricks is the first thing I look at on every SAP analysis. If the bricks on a SAP analysis is less than 6, you are sustaining that plant. You might as well say that plant is in ICU. You're keeping it alive. Once it gets to 6 and higher, it's now sustaining itself. Okay. And the higher you take it, the more self-sustaining it is.
The other thing where we found limitations with tissue in the past and where I feel SAP has excelled is, so last year we're all dry land, for the most part. Most of our customers are. We got a good chunk of irrigation customers, but last year in our dry land customers, we struggled with potassium. We've always struggled with potassium. It just was really bad. Micros were low. But now this year we've got more good rainfall. We're struggling with nitrogen assimilation. And because of the unprocessed nitrogen, we're seeing phos and sulfur being the loss leaders. So what I really like about it is for our business and our farmers we're working with, we shifted side dress programs on the fly this year, different from what we did last year, which was uncommon when we was just doing tissue alone.
I think that, I've seen a lot of that myself. And I think a lot of that, two different things you're talking about there, right? So potassium, like next to nitrate, is one of the two easiest things to get into a plant. Really, when you think of it from a chemistry standpoint. But it comes into conflict with certain things, right? So like mag can cause a lot of problems. But now you're talking about this year with the nitrogen assimilation. So we're getting a lot of nitrogen uptake. Well, when you get all that nitrogen, it's got to have sulfur for that reduction of nitrate to total amino acids and proteins, right? So more demand from the plant for more sulfur. And every cellular function requires phosphorus. So more demand for phosphorus in the currency of the plant. If you think of phosphorus as exchange, currency, economy, so it needs more phosphorus. And it's not that we have a lack of these things, it's just that we're getting better uptake of the nitrogen. Therefore, the things that have to convert the nitrogen are in higher demand. So it's that kind of it's that video game thing. It's like, okay, well, we solved this problem, but now it put a bigger demand on another piece of the puzzle, the physiology. And that's always going to be the struggle. Is like, and so if you fix the sulfur and the phosphorus, now you put a bigger demand on boron, copper, iron, manganese, moly, zinc. We talk so much with the guys. Well, here we sit in Iowa, or if we're in Illinois, large hog producing states, right? So we're putting a lot of hog manure out on these fields. Well, all that phosphorus is just binding up zinc like crazy. And we got fields that have tons of phosphorus, but we can't get phosphorus in the plant. Well, it's binding up, depending on what the pH in the soil is, it binds up with calcium on one side or aluminum on another side. And so it's not that it's not there, it's just that we can't get it into solution to be taken up. And so you got to find another way around, so you go to the foliar, right?
Exactly.
That's why it's got to be the report card. It's not, that's why soil tests don't work. It's like, great, you got a lot of phosphorus, but it doesn't matter if it doesn't get into the plant.
100%.
And so, great, it's there in the soil. We can't get into the plant, so you got to find another route. And the other route onto the highway is foliar. So
bypass the root.
Bypass the roots. Find another route in. And I think guys are getting more comfortable with the concept of foliars.
Yeah, I would agree. I mean, it's becoming more of a topic of conversation. And I think doing stuff like, plant sample analysis, that's one thing, like we see power in it too, is just being able to take those foliar blends now, whatever we're running, say it's phosphorus and micros, and apply it and actually see the plant respond to it in the sap. And give us some validation that what we're using is working, or our recommendations are guiding us to where we need to. And I think maybe you could talk about that, letting Clint, you can highlight it too, is just that as a tool for a metric to be able to measure stuff. We joke, don't joke, but we always talk about like everything in this industry is based off yield, which is important. I mean, you got to, ROIs needs to be paid, right? But this SAP analysis allows us to have another tool in the toolbox to validate what we're doing. Because if I go apply this corn right now, it's probably V8 to V10 behind us, and I apply something and I see it in the SAP, well, it's October before I pull the combine through there.
That's right.
There's a long lag in there, and there could be a lot of things that factor into that. I mean, have other, obviously we have other customers that you work with, or other industries, even crops, do the same things and being able to validate products or looking at their programs, maybe even product, maybe their management styles through SAP to make them feel like they're heading the right direction.
There is. It's the best tool for product efficacy that we have available today, bar none. I mean, dry tissue can't do it. It's the only one that can show, like biologicals. How do you measure whether a biological is working or not working? There was nothing to measure. Now you can put on a biological that doesn't have any elemental you could say, well, this biological opens up phosphorus uptake. Well, until you could measure phosphorus uptake, that was just a claim.
Yeah.
Mm-hmm.
So now you can actually measure it. There have been people that do not like, they thought that their product was going to show improvement, and it didn't. And so there's I guess the negative side of that is that it doesn't always do what somebody wants to show that their product.
What they claimed.
Right. It doesn't show what they claim. The product doesn't do what they think it does.
And we've ran into that many times here. I mean, we find things that really hit home runs, and we can say, hey, we put this much rate on, it's going to move the needle this much at this growth stage. But we found where that doesn't, where maybe we've got to stack the biology with it, or we got to stack the carbon with it to modify how that product works. So I think it's for a business like us that are moving products, it's great for us to make sure we are actually doing what we say we're doing.
Well, I think any respectable company that has the best interest of the producer in mind is going to do something like that. If you're just out there pushing products, then don't use it.
Yeah.
But I tell all my growers that I consult with, the point is, look, if somebody's selling you something and they say it's going to do X, then tell them that you want them to pay for SAP analysis. Do a SAP analysis before the application, do the application, and do a SAP analysis afterwards. 2-3 days. It's not like it's a long process.
No.
You don't need a field trial. If their product does X, you should see the uptake of the parameters that you're looking for. And if the crop actually needed that product, you should see a movement in bricks or some type of improvement in a biological parameter. If it didn't need it, then there's something else missing in the crop. And so you're just putting out a product just to put a product out. How many times have you had somebody come onto the farm that said, oh, well, this is going to give you 20% yield. And the next guy comes out, it's going to give you 10% yield. And this guy's going to give you 30% yield. Hell, by the end of the season, I could have 300% yield increase.
I used to be that guy.
Yeah. And it's just none of it's realistic.
Yeah. No, it isn't.
And so it's like, okay, well, tell me what I'm going to accomplish with this, and let's measure it.
Yeah.
We've got, I had a research place in Michigan that put on a foliar potassium, and we took SAP analysis 4 hours, 8 hours, 12 hours, 24 hours afterwards. And we could see that potassium needle move at 4 hours after application. That's how, on that particular product.
Yeah.
But we also saw like manganese levels moving up, and they didn't expect that. And they were like, well, we didn't have any manganese in that product. Okay, well, doesn't matter. That product, whatever it was doing, is improving the manganese uptake as well. Yeah. So sometimes you discover things that you didn't anticipate.
Absolutely. And that's been our play too. We'll see things with products in early reproduction or early vegetative that maybe we don't quite see in reproduction, but we've got another sink. We've got pods, we've got kernels, so it gets more complicated. But so we use that early window to really validate here, how we moving, because you get that third sink going. It's another big demand on the plant.
Yeah, so. Absolutely. I mean, I think, for the universities, really understanding the process within a crop about the repartitioning of nutrition would be some of the best data we could use today. Because, like in soybeans and stuff, we know that from R3 to R6, we know what nutrients are going to move from the green foliage and in the stalks into the pods. So great. We want to maximize those parameters up to R3, and then from R3 on, it's going to start moving into the pods. So if we want to maximize the bean size, we need to maximize these parameters beforehand. We know in corn and in wheat and barley and such that we need to keep that green stalk as green as possible for as long as possible and get the nutrition there just robust, super robust, because eventually all of that nutrition is going to repartition up into the kernels and into the wheat head. So knowing these things all moves towards better yield, better protein levels, those types of things. You were talking about nitrogen earlier, right?
Yeah.
Okay, so some work out of Israel on a different crop, cannabis actually, is showing that excess uptake of nitrogen is actually hindering the uptake of carbon. So if that's true in other species, when we over-apply nitrogen and have excess nitrogen in the crop, then we could potentially be hindering the sequestration of carbon and the creation of sugars.
We're seeing that this year. And one of the problems we have in the Corn Belt, and, we've got, humidification is an issue for us. We're very humid. Nutrients become available super fast. So, I take West Central Norway, where we was at last year. We got deep freezing, froze 18 inches. We do put a base rate of nitrogen on. A lot of guys put their full rate of nitrogen on in the fall. Mm-hmm. We're probably a half rate in the fall, but I wish I could go back and only put on a 20% rate because we have such high flow. We usually, when we see these high spikes in nitrate and ammonium through carbon, phos, sulfur, micros, we can burn out the nitrate and ammonium. We cannot this year. And even in our impact plots where we're running gallons upon gallons of product because the flow is so great. So, that's a double-edged sword, but it also goes back to the whole point of not overfeeding early because you don't know when you're going to get that year where you need very little in or where you need a bunch, but you can be reactive with the sap and the rapid soil together.
Yeah. And I don't, and I don't farm thousands of acres. Yeah. Kelly would be a much better person to be sitting here next to us talking about this part. I don't know the economics of what it costs to go out there another time and another time versus putting it all out there at one time and losing it.
Yep.
Because once it's out of my root zone, I've lost it. I don't care. You can say, well, it was cheaper to put it out there all at one time, but once it goes out of the root zone, that's a pound of nitrogen you've lost. You can't get it back. In fact, it's just going into the water, which may cost you later on.
Yeah.
But, this feeding it a little bit at a time sure seems to me like we're getting to a place now where I can come up with strategies.
Yes.
And if I can keep that nitrogen in balance and not allow it to get out of control ahead of myself, then I've got more control. I'm in control working with the crop than just throwing it out there and hoping for the best.
And I'm fortunate we get to work with quite a few vegetable growers now in the Midwest, and I'm more jealous of them because of the budget they have and the applications they can make. So we are restrained, I would say, with most of our clientele on corn and soybeans on what's logistically possible, but there's still so much work we can do, to your point, on strategy and splitting this up to alleviate problems, do a better job feeding our crop.
Yeah.
So
yeah. Yeah, there's just a ton that we're still, sap analysis is a small wave right now. And, the science is early. It's a small wave. If the crop nutrition pie is this big, sap analysis is this much of that. I mean, very few people are using it still. But those that are in it on it now, they're at the front of the wave.
Well, just from your opinion and being at the lab level and you do some consulting as well, what are the barriers to entry or some of the hindrances some guys have trying to get into Planet Sap analysis, or what do you hear for feedback?
One, they don't know where to go because there's so few of us doing it, right? There's us. There's a few other labs in other regions that say they do sap analysis, but then they don't know how to give any interpretation. So that's a barrier. If you're just going to get data, then it's just going to be a piece of paper sitting on their desk someplace. And that's worthless. And in my opinion, it harms the sap analysis industry or the use of sap analysis because then they say it's a waste of their time. It's not cheap. The next barrier is, so you find the right lab, hopefully New Age. The next piece is, decide what field you're going to use. Find a field that is one of two things. A, if you get it right, you know it's a big money maker for you, right?
Mm-hmm.
It's a field that you've never gotten right, and you've struggled with it, and you lose money on it all the time. And if you could fix it, it would mean a big deal. So pick a field, and then come to the understanding that, okay, you're gonna probably sample that at least 5 times. The guys that try to do it 3 times, they're just not going to get enough data throughout the season to do anything with. You're going to do it at least 5 times. And then they have to have an amendment provider that can respond to them when they get their data. So they're going to send in, we're going to teach them how to do the sampling. They're probably going to get it wrong the first time.
Yes.
We'll help them through that. We'll help them understand the data. Usually with a new grower, I'll give them 15 minutes, no charge. Here, this is what this is telling you, or they can get with you guys, and they'll get some feedback that way. We'll help them get going with that. And every report comes with a simple interpretation, basic. But they got to have an amendment person that will respond to their need for phosphorus or potassium or whatever that it says that they're in deficiency.
Mm-hmm.
And probably the last piece there then becomes understanding that sap analysis does not tell them to put out 100 pounds per acre, because we can't. It's not soil chemistry. It's you're deficient in this, and you're either deficient light, medium, or heavy. And so you kind of have to take your management and figure out what your product is, and go to the guys and say, hey, I need light or medium or heavy application for that time period.
Mm-hmm.
And then know what you put on. And then when we do the next SAP analysis, figure out what your movement was, right? And so the barrier to entry is dedication and commitment to it, and making sure that you've got somebody that can work with you to get the nutrients that you need.
Yeah, because it's not just a silver bullet. It becomes part of most everybody's plan and part of their program and decision making. Would you say that people that you've seen successful in any industry? I mean, you deal with a lot of different crops. I mean, the people, you talk about cannabis all the time, and that's a big crop for you guys. That they've implemented this over a long time, and they can be very, very precise in their management.
Yeah, we talk about cannabis a lot because it just taught us a lot. It taught us so much because so much of that industry is grown indoors in a controlled environment with multiple, they call them strains, but for us in agriculture, we call them varieties. Mm-hmm. So it's the same crop, but multiple varieties in the same environment, controlled environment, and they all get the same feed. So they're all getting fed the same. They all have the nice static environment. And then we see that all these varieties feed differently. Well, that was a big eye-opener, because I thought, well, the big difference would be that, Mike grows corn different than Clint grows corn. Well, that's not the case. The biggest difference was that you grow there's a difference between the 3 different seed corns that you plant than it was between you and him.
Mm-hmm.
And that was a real eye-opener to me. But the fact that they can drip irrigate and change their feed, and we can dial in that drip irrigation to a very precise formula, that's critical. We can dial that right in all the way through the grow season. Okay, so here's your veg formula, here's your stretch formula, here's your flowering formula, and here's your finishing formula. So, it's not. I guess for us, we would do the same thing for corn. We say, okay, here's your early emergence, here's your stretch, here's your reproduction, and now we want to finish it for the ear fill type of thing.
I think that's you ever want to wonder the complexities of advanced agronomy. Different varieties gather nutrients differently. We had a farmer last year. He had a field with 5 hybrids in it, and we Y dropped the same mix across all of them, and it was a potassium dominant mix. 3 of the hybrids showed a 12 to 15 bushel gain. 2 showed 0. Mm-hmm. Same field, applied the same day, same rainfall. And so it made me really realize, like, wow, when you do have a loss, it may not be because your hunch was wrong. It may be that hybrid or variety you're dealing with is crazy or efficient at gathering potassium.
Yeah.
And so it can still point us in the right direction, but it's definitely a lot going on, a lot to it.
Exactly. So. And, go backwards with that same thing. Depending on the price on those different seed corns, if the other 2 that didn't get the bump were cheaper, mm-hmm. and therefore cost per acre wise, maybe they're the better choice. See, it's all, in the end, I mean, we talked a lot of science and a lot of crop this and crop that, but in the end, it's all about return on investment for the growers. Mm-hmm. None of us are out here trying to win the blue ribbon at the county fair. It's about whether or not we keep the American farmer in business. None of my clients are Cargill. I don't have the guy that's out there with 100,000 acres of canola. It's the guys that have 1,000 acres or 500 acres or whatever, right? They're all trying to stay alive and maybe pass this on to the next generation, mm-hmm. or find a niche or something. And we've got to figure out how to make it pay. What's the return on investment? And the solutions are out there. And, let's go back to the cannabis industry, and this might be offensive to some people, but when the cannabis industry got into play, the same nutrients that were being sold to you and I in ag were being sold to the cannabis industry, but they put a fancy label on it.
Jack the price.
3-5 times more.
Yeah.
Okay. Well, those same industries are doing the same thing to the American farmer. And we've become commercialized. We've become commercialized. Everything we buy: seed, fumigants, fertilizer, you name it, right down the line from the same 5 companies across the board. And I probably just irritated a whole bunch of people. But the fact is, our grandfathers used to know to use bone meal or blood meal or this or that, and they knew the agronomy of what they were doing, and they kept their own corn, and they knew what made heads made good seed corn, which didn't.
Yeah.
Right now, most of our growers buy what the guy coming down the driveway sells them, and I think we need to get back to helping them figure out how to make wise decisions, mm-hmm. based off of.
Well, what's beautiful is I think there's a lot of farmers and a lot of consumers that are wanting change, and mm-hmm. so we're going to be in high demand, and I think we got a great thing going, and it was a great conversation.
Absolutely,
so, a lot of great points, Scott, and I appreciate the time.
Absolutely, anytime.
Come flying all the way out here from Michigan into the great state of Iowa.
Absolutely. Sun shining, can't be better.
Now I know why they call him the Sap Daddy.
He's Clint Frese from Cultivating Agronomy. I'm Mike Evans, and thank you, Scott Wall, the owner of New Age Labs, for coming out here. If you got any more questions on plant sample analysis, please reach out to us at Cultivating Agronomy, and we'll catch you on the next episode of Blueprint to Yield.